The first thing we learn about in 6.4 actually sort of comes from 6.3. So it's called the remainder theorem, and it means if you take a polynomial and you divide it by a factor, then the remainder is the exact same thing you would get as if you plugged a from the factor right into the polynomial. So let me write you some symbols. If you take your polynomial and you divide it by your factor, like we've been doing with synthetic and with long division, you know how sometimes you get a remainder? We'll call it r. Well, that number you get for the remainder would be the exact same thing as if you just took the a from your factor and plugged it in like we learned how to do a long time ago, right here into your polynomial, and it means you'll get the exact same number for the remainder. So let's try one so you can see what the heck I mean. So what we're going to do is we're going to pretend that we're dividing p of x, we're going to divide this polynomial by the factor x equals 4. So since they gave us what x equals, it must have meant that the factor was x minus 4. So we can use, it's sort of like synthetic division, we're just going to do synthetic substitution. We're just going to plug the positive 4 into the box, write down our coefficients, making sure that we have standard form and no skips to the third, to the second, to the first, and nothing, so we're good. So we have a 1, a negative 4, a 3, and a negative 5. We're basically trying to figure out what's going to be left right there in that remainder box. So we drop the 1. 4 times 1 is 4. Negative 4 plus 4 is 0. 4 times 0 is 0. 3 plus 0 is 3. 4 times 3 is 12. And negative 5 plus 12 is 7. So it means our remainder is 7. Alright, that's what they wanted us to figure out. We're basically finding the remainder, what's in that box. So that's how you do that, using synthetic substitution, is what they're calling it. But we could have gotten the exact same answer if we would have plugged in this 4 for x. And if we plug it in here, here, and here. So that's what we'll do. We'll figure out p of 4. We're going to end up getting 7, but just watch. Then it'll be up to you if you would like to do the problems the first way or the second way I'm doing this. So p of 4 is going to be, in parentheses, make sure you plug in inside parentheses, 4 to the third power, and then we have minus 4 times 4 squared plus 3 times 4, and then minus 5. So I recopied that whole first equation, I just plugged in 4. My advice to you is grab your calculator and type everything in exactly the way you see it, all on one line, hit enter, and when you do that, you'll get 7. So it's up to you. You can do synthetic substitution, you can do this. Either way, your final answer is 7. Oh no, I gave you a fraction. Well, let's deal with it. Let's put the negative 1/2 in the box. Let's check our coefficients. 4, 3, oh, I'm missing x to the second. I'm going to have 0 of them. So 4, 3, 2, 1, and nothing. So here are the coefficients. 4, 2, 0, 3, and 5. So we'll drop the 4. Negative 1/2 times 4, in other words, 4 divided by negative 2 is negative 2. 2 minus 2 is 0. Negative 1/2 times 0 is 0. 0 plus 0 is 0. Negative 1/2 times 0 is 0. And you thought this was going to be difficult. It's not too bad so far. 3 plus 0 is 3. Negative 1/2 times 3 is negative 3 over 2. And our final answer, the remainder in the box, is whatever 5 minus 3 over 2 is. If you want to think about it as 5 minus 1.5, you'll come out with 3.5. or 3.5. So that's the answer. You would get the same exact thing if you plug in -1/2 in the equation. You do need to make sure you type it in perfect with all the parentheses and the -1/2. If you really wanted to, you could type -0.5 for all of those -1/2s. And by the time you type it all in, it will give you 3.5 for your answer. So either way, I will accept it. Now we're going to jump to section 6.4, and here's where you learn the factor theorem. It goes like this. If you have a polynomial, x minus a is a factor, if and only if the remainder is, it has to go into it evenly, so the remainder has to be 0. What does that mean as far as the substitution we just learned in the previous example? It means if you plug in the number from the factor, it means you'll get 0 as your answer. So another way to write it is if p of a equals 0, then x, and if this is a positive number inside, then it means that it was a minus inside the parentheses. Then it means x minus a is a factor. And the same thing would be true if p of negative a. If you had a negative number that you were plugging in, then it means that x plus a would be a factor. And then the other way around, if x minus a is a factor, it means that your remainder is 0. If you were to plug in the number, you'd get 0 in the box or when you type it in. So let's apply that to these examples. We're trying to figure out if the factor they give us, if it divides evenly into the polynomial they give us. So like if I asked you, does 5 go into 12? Well, no, because 12 divided by 5 is a decimal, right? But if I asked you, is 3 a factor of 12? Well, yeah, because 12 divided by 3 is exactly 4. 4 remainder 0, right? So we say 3 is a factor, but we'd say 5 is not a factor. So basically, these are yes or no questions. Is this a factor of that? Yes or no. So what we have to check, we just have to see if the remainder is 0. So let's take the -3, put it in the box, and make it positive. I'll check for standard form to the second, to the first, and no x's. We're good. So my coefficients are 1, 2, and -3. Drop the 1. 3 times 1 is 3. 2 plus 3 is 5. 3 times 5 is 15. -3 plus 15 is 12. So is that a 0 in the box? I don't think so. So guess what? X minus 3 is not a factor. Alright, this did not divide evenly into that because we have this remainder right here. So our answer is no. You could have gotten the same answer if you would have plugged in +3 into p of x. If you would have done 3 squared plus 2 times 3 minus 3 and typed it all in, you would have gotten 12. And your answer still would have been no. Let's see if you can try 2b. You can do it either way you would like. It doesn't matter. You're going to get yes or no for your answer. I did synthetic substitution. I plugged in -4 into the box. I noticed that we skipped x squared, so I filled in a 0 for the x squared. And look, I got 0 for the remainder. So this is a big fat yes. X plus 4 is a factor of that. Alright, I'm approaching the 10-minute mark for this video, so just keep in mind the rest of this is a review. We already learned how to factor. I'm just refreshing you. So if you remember everything there is to know about factoring, that's wonderful. You might be able to skip this part of the video unless you come to something and you can't remember how to factor it, then you can watch this. Number 1 rule is you always look for a GCF. So let's factor 3a. These are trinomials, which means we have 3 terms. That means after we look for a GCF, then we can factor it pretty quick, hopefully. So a GCF, it looks like we can divide all those numbers by 2, and they don't have all of a letter. So I'll write the 2 out front, and I'll write the leftovers. 2 divided by 2 is 1. Negative 10 divided by 2 is negative 5 with an x. And negative 48 divided by 2 is negative 24. Now I can find the factors of 24 that subtract to get negative 5. I'll recopy the 2. I'll set up my 2 factors with an x and an x on the inside. And what multiplies together to get 24? 1 and 24, 2 and 12, 3 and 8, 4 and 6. I'm trying to get negative 5 out of this. So it looks like 3 minus 8 will do the trick, right? Positive 3 minus 8. That would give us negative 5. And that's it. These directions say factor. These are factors. So this is your final answer. You don't have to keep going and solve for the zeros. That's going to come in section 6.5 and 6.6. So we have to look for a GCF. Do we have a GCF? We can divide all 3 of those by. Looks like a 3. And then what about the letters? We can divide all of them by x to the 3rd. It'll get rid of all of those at the end. So let's put our GCF, the 3x to the 3rd, out front. And I'll write the leftovers after it inside parentheses. 3 divided by 3 is 1. 5 minus 3 is 2. So it'll be x squared. 12 divided by 3 is 4. 4 minus 3 is 1. So just x. 9 divided by 3 is 3. And those 2 cancel out. So, one more step. Recopy that GCF out front. I have 2 sets of parentheses. And I'm trying to find the factors of 3 that add up to 4. Well, I hope it's 3 plus 1, because those are the only factors of 3. And 3 plus 1 is 4. So these are the factors. They are inside parentheses. We don't have to do anything else right now. We're just refreshing how to get those factors. I'm going to show you grouping for 4A and unboxing for 4B, because I taught you both ways originally. And I think most people like unboxing. That's pretty much what I'll use in the future. But just in case, I'll go over grouping again. We have to do grouping when we have 1, 2, 3, 4 terms. The whole factors of C that add up to B, that only works for trinomials with 3 terms, and we have 4. So if we have 4 terms, and we try to find a GCF that we can divide all of them by, we can try. However, it looks like the only thing we can divide them all by is 1, so that's not going to help us. So what we do for grouping is we chop it in half after the second term, and then we look for a GCF of the first half and then the second half. So the GCF of the first 2 would be x squared. So I can divide both of those by x squared. So I'll write the x squared and I'll write the leftovers next to it. 3 minus 2, x to the 3rd divided by x to the 2nd is x. And those cancel out, so I'm left with a plus 3. Now I do the same thing over here. I notice that both of these have a negative sign, so I'll factor out a negative, and I can divide both of them by 4. So I'll write that GCF, and I will write the leftovers next to it. Negative 4 divided by negative 4 cancels out, and I'm left with x. Negative 12 divided by negative 4 is positive 3. So now I'm so happy because now when I go and look for a GCF, now this and this match up. So what happens is you divide by, oops, that's x plus 3. Divide both sides, both the blue and the red part, by that GCF, and they cancel out. You can just cross them out if you want to. And so we have x plus 3 is a factor, and then the leftovers, x to the second and minus 4 go next to it. So all of this still equals 0. We have to make sure we factored everything completely. So I notice, since I have an x to the third up here, that there must be 3 factors, and I only have 2. So I really can't do anything else with that first one, but the second one I actually can. So I can find factors of 4 that subtract to get nothing in the middle. See how there's no plain x in the middle? So I'll recopy the x plus 3, and I can find factors of 4 that subtract to give me 0. It's 2 and 2. If I take x plus 2 and x minus 2, they cancel out, so there's nothing in the middle, and then when you multiply them, you get negative 4. So now I have 1, 2, 3 factors. It matches up with that first exponent, and that's the final answer. I told you I would do unboxing for this example. I have 1, 2, 3, 4 terms. I should see if I can divide them all by a GCF, but I can't. So if you really like grouping, you can do grouping. Otherwise, I'm going to unbox this. So I'll put the first term in the first box, and then I'll keep copying the other terms in the other boxes. And the 25 goes last. And now we just pull out GCFs from each row and column. So looking straight across the first row, the GCF of 8 and 4 is 4. And for y to the third and y to the second, it's y to the second. Next, the GCF of negative 50y and 25 is 25. And whenever you have a negative sign in the first box, you always pull it out. So that negative is going to come out to the side right there. Next we look down the columns. The GCF of 8 and 5 is 1, and of y to the third and y is just y. And remember, I already pulled that negative sign out, so I don't have to worry about it. Last, I look straight down this column. The GCF of 4 and 25 is 1. That has a y, that one doesn't, so just a plain 1. I should point out that this first box has a negative sign, so I do need to pull that out. So let's double check. This is sort of a new reminder I have for you. Double check that that the box works out. Because before, I always gave you problems where doing this would work, but we're going to come to some problems down the road in section 6.6 where unboxing doesn't always work out, and you have to do something else. So let's double check, because I already noticed that I made a mistake. Is 4y squared times y 8y? Nope. Is negative 25y times y 50y? No, and it's because I neglected to write down that the GCF of 8 and 50 is 2. So it's not that this didn't work, it's just that I didn't pull out the 2 for the GCF. So now 4 times 2 is 8. Y squared times y is y to the third. And now negative 25 times 2 is negative 50. Let's check the rest of it. 4y squared times negative 1 is negative 4y squared. And last, negative 25 times negative 1 is positive 25. So let's write those factors in parentheses. We have 4y squared minus 25. And we have 2y minus 1. So I have 2 factors right now, but this is a third, so I should have 3 factors. So I can't do anything else with this one. This one's going to stay. But I can find factors of 25 that subtract to get 0, because these are perfect squares, and that's the next example. But in the meantime, here's two sets of parentheses. What times what? What times itself gives you 4y squared. 2y and 2y. And 5 times 5 is 25. And if we put 1 plus and 1 minus, then they will cancel out to give you 0 in the middle. So now we have 3 factors and we have our final answer. Now let's practice just factoring perfect squares. We already kind of practiced them in those examples up above. But we want factors of 16 that subtract to give us no x's in the middle. So, x times x is x squared. 4 times 4 is 16. And if we have one positive and one negative, they cancel out to give us nothing in the middle. For 5b, the two factors we need, what times what gives you 4x to the fourth? Two of the exact same thing. Well, 2 times 2 is 4, and x to the second times x to the second is x to the fourth. And then what times what gives you 49? 7 times 7, one with a plus, one with a minus. I do know that we should have 4 factors, however, we can't use that plus minus trick with this one, because it's a plus sign right here. And with this one, we can't find 2 of the same number that multiply together to get 7. It's not a perfect square. So for this problem, this is as far as we can take it. Eventually we'll learn how to keep going, but for now this is good. I just had to throw in a story problem. So we have the volume of a cargo container. It's modeled by this function right here. You have to do 2 very simple things. You have to identify the values of x for which that polynomial equals 0. So let's look at the graph. What values of x does the polynomial equal 0? You just have to identify where it crosses the x-axis. Here, here, and here. So according to the scale, it's going by 2s, 2, 4, 6, 8. So halfway in between the 6 and the 8 is 7. So 7 is one of the values. This would be -2. So -2 is one of the values. That'd be -4 and -6. So right there would be -5. So our answers are x equals, and we're going to write 3 separate ones for each of them. X equals -5, x equals -2, and x equals 7. Now that we've written those 3 separate x's down, we are going to write down the factors. Well, since those are the zeros, all we have to do, we have 3 zeros, it crossed 3 times. We just have to write them inside the parentheses. So to put them in the parentheses, we flip the signs back. So instead of -5, we'll have +5. Instead of -2, we'll have +2. And instead of +7, we'll have -7. And those are the 3 factors. Done.